Good afternoon and welcome to Covéa Talk Digital on MLOps and deploying machine learning into production with Alex Waters, a fellow data scientist here at Covéa, and our guest speaker, Tom Farrand, a solutions engineer from Seldon. So I will share my screen with me. Okay, so just an overview of what we'll be talking about during this talk. To get started, I'll outline what the talk's going over. I'll be starting off with a little explanation on MLOps and where its difficulties lie and why it's hard to deploy, monitor, and update ML models once deployed, and where Seldon sits within our stack. Then I'll pass it on to Tom Farrand, who's going to be talking about Seldon and the technical details behind Seldon, and how it actually overcomes these challenges in MLOps and deployment of models, etc. Then I'll pass it on to Alex Waters, who will finish off with a live demonstration of the Seldon platform at work, and we'll pray to the demo gods that everything's going to go well with his demo. So finally, I'll cut it all off with some questions that can be asked at the end of the talk, and I please ask everyone just to mute their mic while the presentation is going on. Okay, so first off, I'd like to ask the chat, what is behind all machine learning projects? What would you think? What would you say is behind all machine learning projects? What would your answer be to that? If you'd like to type into chat what you think. Okay, so what I was looking for is a model lifecycle. And what do I mean by that is every machine learning model starts off with some sort of data. We do some sort of data versioning, we do data validation, and often we do some pre-processing of the data so that we can take real world data and map it to something that our model understands and can ingest. So we retrain the machine learning models once we're settled on the architecture. Then we often do some tuning of the machine learning models. If we analyze the models, we usually do some validation around, for example, how the model is performing and whether it's performing better than the previous model we've seen. We talk about deployment. Once it's outmeasured the previous model's performance and the user's happy with it, then from that we bootstrap some new training data and the whole process kicks off again. So this basically means it's an eternal life cycle, and if you do this as a data scientist the first time, it's always quite fun, but as you do it the second time, the third time, the 10th time, the 100th time, well, it gets really boring. And that's where we want to automate these processes, and that's where MLOps comes into play. So MLOps, I've got a model, now what am I going to do with it? So what exactly is MLOps? MLOps is bringing culture and practice, which aims at unifying ML system development together, so the dev part, with the ML systems operations. This is to build quality ML systems, and it's important to unify the ML development and operations and advocate some automation and monitoring of these ML systems. And this is where MLOps comes into play. And I know I shouldn't really use some wiki definitions that I found, but I thought this one was a really good explaining what MLOps actually is defined as. So it's defined as a compound of machine learning and operations. And it's a practice for collaboration and communication between data scientists and operation professionals to help manage these production ML life cycles. So what do we actually mean by MLOps? What does it actually contain? So if we take an ML lifecycle, Usually we have data where you'd like where you do any kind of cleaning, data cleaning, and any type of feature processing or data processing, etc. And then we go on to the training, where you would do some sort of actual training of your model and an experiment tracking, etc. And then you would expose the model to deployment to serve your model to the users. And this is one of the most difficult steps in the ML lifecycle. So if we think about a Jupyter notebook and work within Jupyter notebook, you can't fit this whole life cycle within a Jupyter notebook. You just can't do everything there. So we need to think about things like, can we track the data lineage? And how can we monitor the data lineage? Keeping track of and managing different workflows that we may need to clean our data. How do we alert if something goes wrong with those workflows? And also labeling our data. If you think about training, we need to think about how to distribute the training and how the experiment tracking works, etc. And then we need to think about the serving of the actual models, packaging our models, for example, or the day two concerns like monitoring our models and audit trails and even explainability of the results from our models. This is all something to think about after we've actually deployed it. So there's much more than just deploying a model. It's also, monitoring and explainability of it. ML ops, things to consider, and the general consensus here is deployment, auditing, and monitoring of models isn't as easy as it seems. Everyone thinks that, we have these models and that's it. We create the models and that's it. Here at Covéa, we wanted a software that would solve our issues within ML lifecycle and make it a lot quicker, a lot more manageable. And it allows us to get the product shipped with a high quality to the market as quickly as possible, therefore increasing profitability. I took a report from VentureBeat that said almost 90% of models don't even make it to production. That's how hard in some companies it is to get these models to production reliably. That's why I'm stressing a lot here and to saying that, deploying your model is not always an easy feat, and you have much more to take into account even after deployment. Some of the things we have to take into account. So, for example, it's how to monitor these models, update these models, check for the performance, the accuracy, check even if the data that has been input, if the distribution has changed in respect to the training sets. And there's a wide set of requirements within ML life cycles. If you think about different challenges that we find, for example, if you focus on the deployment part, different data scientists like to use their own framework, maybe because they prefer it and they have expertise in that framework, or maybe because they use it for a specialized purpose, which makes sense for that use case. We don't want to constrain the data scientists just to one framework. For example, they may use TensorFlow for one, or they may use XGBoost for another. So here you really see an axis of variability that you need to think about when you design an ML lifecycle. It's not just as easy as everyone thinks it is to build models and put them into production. Another example is the monitoring your model. It's not just about monitoring your CPU memory or your CPU or your memory. This is maybe about detecting that a data point at inference time is an outlier, or that a data set and the data that is appearing at inference is drifting away from your training set. How do we know that's happening? You need something to check it in real time. These are technically challenging problems, especially in real time. You need to think about if your model needs to be retrained and put this model through the whole life cycle again, and how to do that without disrupting production. So you need to think about how to scale that up to the next level. Then, last but not least, this is one of the most important parts, is within an organizational challenge that MLOps gives you, is when talking about MLOps, we need to consider how to overcome these barriers. And DevOps, for example, tries to solve by automating as many processes as possible. So you give the power to the engineers to own that particular infrastructure. And that's where we see Seldon going, to allow us data scientists to own their model in production as well. This image on screen comes from a very popular Google paper called Hidden Technical Debt in Machine Learning Systems. And as you can see from that right-hand side, which is highlighted in red, this is where we see the Seldon platform essentially trying to solve. And we'll see some of the live demos later on in the talk. So the goal here is to bring together the two sides, data science and DevOps. And we want to bring the two types of people to work together well on a machine learning project. So we have data science, whose obvious use cases are doing the core algorithms and data analysis. But then to get it into production, they're going to work with the DevOps engineers. And these people sometimes don't have a good understanding of, machine learning and don't really know how it's going to work. And also sometimes the data scientist doesn't want to get involved in the DevOps side of things. They just want to do the data science at the end of the day. So how do we get these two key components together, working side by side? These two people have to work together well for a machine learning project to actually be successful. And really, it's the sort of goal where Seldon sits within Covéa. This is where Seldon sits here. So this is where it sits into the puzzle. We're using Kubeflow and GitLab pipelines to automate the training, deployment, auditing, and monitoring. And Seldon core sits within the rollout, serving, monitoring, optimization. Here I'll pass on to Tom Farrand to talk more about technical aspects of the Seldon platform.
Cool, thanks very much, Jordan. So, hi everyone, I'm Tom Farrand. I am the imposter. So I work for Seldon as a solutions engineer. And here at Seldon, we're fanatical about getting machine learning models into production. And I'll build on what Jordan touched on. We'll look at some of the fundamental challenges that are involved in that MLOps journey, and also some of the technology that Seldon brings to the table in order to solve these. This is going to be a little bit like a government briefing. And Jordan, I'm going to have to ask you to go to the next slide, please. So I'm going to be focusing on 4 fundamental components of machine learning operations. So that is the deployment of those models, the monitoring of them in production and understanding their health, the management of a huge volume of these models across multiple different environments and the challenges that brings. And then, of course, in a regulated and compliance-heavy environment such as insurance, which Covéa operates in, explainability is a key factor as well. So what I'm going to touch on are some of the challenges introduced in each of these within each of these components, but then also the technologies that Seldon introduces as well. So next slide, please. Thank you. So Jordan, I think, did a great job in laying some of the groundwork around the challenges that are introduced in the deployment phase. So this is where you're taking a trained machine learning algorithm, Alex or Jordan or Tom, Clay or Ashley from the Covéa team have put their blood, sweat and tears into creating an algorithm. But if that then doesn't get into production, there's no return on investment. There's no business value generated. And so this is a crucial step in turning your data science function from that which deals in proof of concepts or experimentation into one that actually delivers real business value for Covéa's bottom line. And so I think Jordan really nicely fleshed out some of the challenges that you have around variety. So data scientists love using the latest shiny toy, whether that be framework or programming language. And so you need to be able to support a variety and a kind of complex landscape of different tooling there. But additionally, companies and large enterprises like Covéa will have infrastructure and models that are deployed both on-premise as well as in the cloud, and potentially even across multiple clouds. And so there's that added complexity of where it's running as well as what is running. And so really where Seldon looks to solve this issue is we leverage Kubernetes very heavily. And so this allows us to run on essentially any sort of infrastructure. We then have data scientists containerize their models into Docker containers, which can then run on that Kubernetes platform. And we provide tools such as source to image, which makes it easy for data scientists to take source code and convert them into those container images, as kind of the expertise in these infrastructure technologies is usually not where users of the platform or data scientist skill set typically lies. The next piece is then, once it's deployed, how do we serve it and what challenges are related there? So not only do we now have to get data to our endpoint, there are multiple different ways of getting that data to it. So we can have a real-time use case whereby we need the results back as soon as possible. We could then have large batches of data that are run on a certain schedule, but then finally we could stream data to it and have an event-based architecture. All of these different situations need to be catered for and worked into our plans. The second piece then, and I think Jordan already mentioned this, but is around how do we upgrade? How do we roll out new model versions? And crucially, how do we make sure that the version we have in production is the most accurate and the best model that we have available? And so that's we can use things like A/B testing, canary and shadow deployments, but also more complex deployment methods like multi-arm bandits, where you essentially route traffic. You basically compare and contrast various different machine learning models using another machine learning algorithm. So it gets a bit meta there. And the technology that we use for that, Seldon saw this as a huge gap in the market. There wasn't anything that could really fill this requirement to serve and deploy these models out. And so that's why we developed Seldon Core and integrated it into our enterprise platform, which Alex will show off soon. And so Seldon Core really helps you realize all of these different use cases, as well as serve the model endpoints as you would like to. The final piece then that kind of stumps enterprises around the deployment portion is self-service. So we at Seldon believe that data scientists should and can be able to own the entire life cycle. And we typically see in organizations that, a data scientist will train. So Alex will go away and create a very complicated and opaque model. They'll then throw that over the fence to a DevOps sort of team. And they will then be tasked with actually taking this really complex piece of code and deploying it into an even more complex environment. And so what we try to do is actually streamline that and ensure that Alex can deploy and own his own models while abstracting away a lot of the complexity that comes with that infrastructure kind of technology that the DevOps folks are experts in. And so that's why you see the little octopus, the Argo logo. So this is where CI/CD pipelines come in and some of those flavors of automation, whereby a data scientist can click go and a model deployment can be created. And so a lot of that complexity is abstracted away, and all the data scientist has to focus on is the model that they're creating. So next slide, please. The second component is then monitoring. So once that deployment's out in the wild, how do we make sure it's doing the things that we want it to? So a great example of this is well, not a great example, depends on your perspective, but Microsoft Tay was a Twitter bot that was released into the wild, and it basically responded to tweets based on the tweet that it received. And so very quickly, I think after less than 24 hours, it was xenophobic, homophobic, racist, all of the above, and Microsoft had to pull it down. So how do we avoid these, awful situations whereby we've deployed a machine learning model into production and it's gone completely haywire? And the answer to that is monitoring. So here at Seldon, we see this splitting out into 3 separate distinct challenges. The first is infrastructure monitoring. And this is the same, and this is less of a challenge because it's kind of translated over from traditional software. So how do we monitor and meet our SLAs? How do we make sure that our model responds in the correct amount of latency? It can deal with the throughput that we're expecting from our users. Can it scale up or down? And how does it and how can it handle and track resource utilization? So we make sure we're not burning through thousands of AWS credits. So here we make use of Prometheus, which is a cloud native tool that excels at collection and storage of those metrics. We can then visualize those in dashboards and surface them to the users. Now, the metrics that can be collected by Prometheus don't just stop at those that are related to infrastructure. We can also make use of data science relevant metrics. So these are things like accuracy, precision, recall, mean absolute error. And we allow data scientists to come in and customize these points, but it's critical that these are tracked as well, because this is just as much performance as how the latency or the request per second. If the accuracy is dropping over time, we need to be alerted and we need to retrain or take remedial action. And so again, Prometheus comes to the fore here, but also some of the tools that we've built around Knative. And so this allows us to spin up containers in a serverless fashion to track real-time metrics and then spin them down when they're not needed anymore. So this doesn't impact the serving of your model, but gives us that added capability. The final category then, I've kind of titled advanced. And so this is actually the monitoring that can be used to inform critical decision making. So when do we retrain our models? How do we curate new training data sets on the data points that really matter? So this is where drift detection, so understanding how the distribution of our data is changing over time, and crucially, whether that's having a negative impact on the performance of our model, and outlier detection really come into the fore. So outlier detection, picking up those anomalous data points. And so within Seldon Alibi, which is our open source Python toolkit, we've got a huge different range of algorithms created by our data science team, who are far, far more intelligent than I am. They've got a massive range of different algorithms that can track the drift and the outliers across a number of different data types and use cases. So if we could go on to the next slide, please. The third component then is management. And this becomes really critical when you're an organization like Covéa and you want to scale and actually bring multiple people together to collaborate on a deployment and on your deployments at an enterprise level. So scaling up to hundreds or thousands of different machine learning endpoints when there are tens of different versions of that machine learning model spread across a number of different environments gets complex very, very quickly. And so this again, we turn to our friends at Argo and other CI/CD pipelines, so Jenkins, Spinnaker, and we look to automate this process. We don't want to be spending, huge amounts of time creating and managing these deployments. We want to make sure that that process is as smooth as possible. And so CI/CD, and this is where the DevOps component of the MLOps world comes in, is brought in to automate and make use of those. And so Kubernetes is also a huge driver here because it allows you to have a declarative state for a lot of your components. So rather than saying, so you can specify your configuration, and that can then be created on any cluster in which uses the Seldon technology. So we have portability and automated creation, which is really powerful. The second piece then is multi-tenancy. And so data science is a team sport. It requires lots of different folks to work together in order for it to be successful. And so we need to have a multi-tenant environment. Everyone needs to be able to work together on a single platform in order to get the job done. And so this is where things like Keycloak and DEX come in, as well as role-based access control, so that we can ensure that people can log into the platform, see the things that they care about, and don't have to worry about any of the permissioning, etc., around those. And it also means that the ability to lock down certain environments whereby we don't trust Jordan to deploy into production, but we do trust him to deploy into dev. No offense, Jordan. It may still be useful that Jordan is able to monitor and view the models that are deployed out into production in order to keep an eye on the health and the performance of those. So you can have these interesting ways of working added as well. The final piece then is around audit. And so understanding how a model has changed over its life cycle. And so, when was it deployed? What was actually deployed? How was it deployed? And then how has that been updated and rolled out and changed in time is really, really powerful. And additionally, to prevent, so if things do go wrong, the ability to roll back to previous states is another thing that needs to be considered. And so this is where Seldon makes use of GitOps. So I mentioned the kind of configuration file, the declarative state of our models. That's all pushed to Git, and any change to that is then versioned with Git so that you have that ability to roll back. You have the ability to audit those model deployments about what's gone where and what that actually is. And then this is all brought together in our enterprise platform. So next slide, please. The final piece of the 4 fundamental components is explanation. And so this is hugely relevant to Covéa, given the regulated environment, as well as the kind of compliance requirements that are in place in the insurance industry. And so we'll touch on some of the challenges. Again, variety rears its head. So, as I mentioned before, data scientists love new algorithms, and so they're always constantly it's a constantly evolving landscape, not just in the tooling that is used to create models, but also the algorithms that are used to explain them. So we have to be on top of that, which is why within our tooling, we introduce kind of state-of-the-art open source algorithms such as SHAP, counterfactuals, accumulated local effects, etc., to make sure that data scientists have the range and the breadth of choice within their tooling that we provide to make the explanations that they need. In addition to that, we provide the ability for extension and customization of those tools. So the next piece is compute. Explainers are actually really quite computationally expensive to run. And so if you need to produce a huge batch of explanations, that can be both time consuming and expensive. And so in a production environment, this could be restrictive and could actually impact other kind of latency or throughput requirements. And so here we actually fall back to distributed computing frameworks. So we've got a kind of a beta sort of feature within Seldon Alibi that makes use of Ray as a distributed backend. And this allows us to spread the computation across lots of different nodes so that we can return those results quicker, and we can also process more explanations and get around some of these challenges with compute. The final piece then is integration. So explainers need to run alongside models in production. There has to be a close-knit and tightly knit integration between the two, as explainers essentially reverse engineer the models they're deployed with. And so this is why Seldon Alibi is built with close thought to the rest of the Seldon technology stack, and all of the open source algorithms that are included within that have a view to being integrated with the wider technology landscape as time goes on or in the immediate term. So if we could go to the final slide. Just to conclude, before I hand over to Alex to give you a demonstration of Seldon Deploy, I've touched on some of the challenges that are introduced with the kind of 4 fundamental components of MLOps, of deployment, monitoring, management, and explanation, and then touched on some of the cloud native and automation tools that Seldon makes use of in order to help solve these challenges. So I will stop rambling. I'll hand over to Alex to get into the exciting stuff of showing the tool off. Alex, I don't know if it's just me, but you've gone a bit robotic.
Yeah, you've gone a bit.
Can't hear you.
Do you want to try restarting Teams? Or it could be the microphone, possibly.
Is it better now?
There you go.
That's perfect.
Okay, cool. Yeah, I'm Alex Waters, one of the data scientists at Covéa. So Jordan and Tom covered a lot of different sort of capabilities of Seldon and sort of the sort of features that we'd want from MLOps. And I thought I would sort of zero in a bit on the stuff that I really care about as a data scientist, the things that really enable me to be able to provide value, using my skills to provide value for the business. So if I was to sort of, grab a few things that I could demo now, I obviously care about having compute power, having the right sort of machines for the right sort of job. But the truth is that nowadays that has been so capably dealt with by the various kind of cloud providers and things like Kubernetes that actually, as a data scientist, I don't even really need to talk to people about that anymore, because I know that things like the Kubernetes platform and AWS that it's sitting on is handling so much of that so capably that I don't really need to think about it. And that kind of comes without, as I said, like without even kind of thinking or discussing it, that comes with a platform like Seldon. So the things that that are really on my mind are things like having a solution that's easy to work with. I don't want to change the way that I work in order to fit in with a platform. I want to be able to work in the way that is familiar to me, push things to production and be able to make changes to them easily. I also want to be able to audit things and see if things have changed. If someone asks me a question of, why is it no longer doing such and such, or why have things changed, I want to be able to follow that right through to a line of code that me or my colleagues might have written, all the way through to the user of it. And I also want to be able to integrate my work with the rest of the business. So I don't want data science to sit in something that's separate to the operations of the business. I want data science to be in the operating model of the business. I want the applications that we create as data scientists to be just as in production as things like our claims app or our pricing engine, the core things that enable the business to function. So I'm going to try and show some of that capability. I'm going to share my screen. Okay, so I have here, this is a deployment on Seldon Deploy. It's called Claims Predict, and it's an imaginary app that tries to predict the number of claims that we're going to have. So first, I just want to show you how familiar it is to me to have created it. So I've started with, say, your standard sort of Jupyter notebook, kind of hacking around in there. Once I'm happy with the exploration that I've done in Jupyter or wherever I wanted to do it, this is all just done on my laptop. Really, at Covéa, our sort of development platform for data scientists is something called Kubeflow, which sits very nicely with Seldon. But for tonight, we're just talking about stuff that's been done on my laptop and then going straight to Seldon. So once I'm happy with the development that I've done and I've got a model, I might say write it up in summary. So in this single script, I'm grabbing my data and maybe doing some transformations on data. As you can see here for this example, I'm literally just creating a log function and some dates. If this was more complicated data, then I might have a separate script for how to handle data. I'm then training a time series model. So this is called Profit, which is something that the data science team at Facebook open sourced. It's a time series forecasting model. It made quite a lot of noise when when it was released. It's pretty capable. So here I've just created the simplest fitting. I haven't tried to change any of the parameters for this demo, and I'm just fitting it against our data, and then I'm writing out using the familiar pickle from Python, and I'm writing the model out. Then, in order to get that to work in Seldon, so this would be considered a custom model in Seldon because it doesn't use sklearn or MLflow or some of the things that are sort of a bit more pre-packaged in Seldon, but that's absolutely fine because you can write whatever you want, which I will show you here. This is an app that can be that can be deployed to Seldon. It's not the entirety of it, obviously. There are other things, as you can see, that sit alongside it. But this is what's doing the main work. This is the main stuff that I've defined. So you can see it. It loads in the model that I created in my development work, and here, this is where it's going to make a prediction. And you'll notice that I've imported pandas, I've imported pickle. These are really, really standard data science Python packages. And given that this is all in Python, I have got quite a lot of flexibility of what I'm going to write in here. So none of this was specified by Seldon. This is stuff that I've written, and I could write all sorts in there, because essentially the app is just going to call this function and it's going to run what it needs to do. It does obviously need to return certain things for, a certain type of prediction for Seldon to handle, but the steps in there, you've got quite a bit of flexibility for what you can do in there. When that is deployed, you end up with something that looks a little bit like this. So this is the app that has been deployed, and you can see here how you can sort of monitor the different requests. You can see we've had 7 requests. I made a failed one as well, so you can see that's a 400 response, which is a bad request because the data wasn't structured quite correctly. And there's all sorts of functionality you can do in Seldon. As I said, I'm not trying to show everything. I want to really focus. So something I mentioned before was about having the model and the data science work integrated with the rest of the business. So an example of that would be, say, here. Imagine we had this web app. So again, just something that I literally wrote today. You can see it's just running locally on my laptop. But imagine that this was something that predicted the volume of claims for Covéa. And let's say we were to put in a date. Let's start at the beginning of 2020. And we were to submit that date. And there we go. So this app would send a request to the model that's deployed on Seldon. Seldon would pass it back some data, and the app would then display it. So it's saying, right, the actual number of claims out was 605. The forecasted figure was 604, so that's good. We've got this green bar here because that's excellent. We've forecasted there and there about correct. And here we have a graph just showing the prediction line and the actual line. As you can see, they are implausibly close together because this is just the log function, which is quite easy for Prophet to predict. But let's say over time the model started losing its level of performance. If we jump to about a year later, remembering this is the log function, suddenly we've gone orange. And we can see here that we had 402 claims, but we'd really forecasted 421. And you can see here where the time series forecast is starting to lose track of the increasingly curved log function, and we're starting to see that gap. And of course, as we jump further in time, we will see those two things come further and further apart. So that's in the future. So if we were to say jump to the 25th of Feb, yeah, so now we've gone red, and we're saying that the actual was 221, the forecast was 325. So we're starting to see a really big gap between the forecast and the actual figures. So it's at this point that you would start to think, okay, we want to change this model. We were happy with it, it's degraded over time, and we want to make some changes to it. So let's say here, so I'm going to do it really simply, but I'm going to do it as live as possible. So instead of training our model on everything, I'm going to just train it on the last 50 days, let's say. So I save that. So I've got my repo for the model and the data that it's running on. This is source controlled in Git. So we should see, yep, that Git has noticed that we've made a change. So we're going to add that change. I'm going to add a message so that we know what change we've made. So I'm just going to call it changed the data recent. Okay, now I'm going to need to connect to our VPN. This is always a little bit risky. Okay, you might lose me for a second. Okay, so I should be back again. Now that I'm connected to the VPN, this should work to push the change. There we go. And now I'm going to show you some clever stuff that makes people like my job much easier. So this is the remote repository for our claims predictor. And if we just refresh this page, we should see, yeah, there's our change. So change the data to recent. And what that's done is it has triggered GitLab to, there it is, change the data to recent to trigger off a GitLab pipeline, which will then trigger a Jenkins pipeline to do the whole build for me. So it's going to, so I don't want to have to rebuild the image that Seldon is going to deploy. So we've automated that whole thing so that the data scientist's job is made as easy as possible. So Jenkins is going to automatically do the build for me. It's then going to push it to something called Harbor, which is where we store our images. And then it's even going to, because Seldon has an API to allow you to deploy things remotely, it's going to deploy the image that's being stored in Harbor, is going to deploy that to Seldon for me as well. And I will show you how auditable this is. So if we have a look at the audit logs for this model, we can see here that I've deployed it twice, and Seldon is showing us here the difference between. So it looks, you know, for those of you who aren't kind of used to software development, you'll really recognize this sort of red and green substitution. So red is something that's been taken away, and green is something that's being added. And we can see what's changed, and we can, and you know, if we were investigating what's going on with this model and what might have changed, we can see here that it's the image itself that has changed, which is a very, very significant change. And we can see that the image tag has changed from 84B to 76A. And we can trace that right the way back from the Seldon model that sits behind our business applications, all the way back to a line of code that someone has changed. So that's 76A and 84B. If you try and remember those numbers, there's 76A. So Jenkins did build number 27 with that same number. That was a revision. We can see here 76A, where we saw that the 84B changed to 76A. Those are the two different images. We have still got those two images. We haven't destroyed, the images do not get destroyed automatically. We've still got them. And that's something which is really, really important at Covéa, that ability to go back in time and see why our software did the things that it did. So we could always, you know, bring those images back. But the best thing, especially for a data scientist, is that we can trace this back to an actual code change. So if we have a look, I'm going to have a look at the commits that have gone into this repo. So there's 7.6a, and we can see there that it had a green tick, which meant that it triggered the pipeline and the pipeline passed. And back there was the last time that the pipeline was triggered. So anything between those two green ticks are things that have been changed. And if we were unsure about what had changed and why, we could click in. And again, we're seeing the similar thing with the green. We can see exactly a line of code that has been changed, which has then gone all the way through and caused the model to change its prediction. And we should see by now that change that we actually commit together. Let's see how it's going. It's finished. Okay, so you can see there 5 minutes ago. That was the change we did together over here. That change to make the data, to make the model train on the more recent data, because the trend was changing so much. So that change, and that's completely rebuilt our model. So we should in here now see, we can see we've got three. We've got three images, and we've got a new tag of 80A. And with a bit of luck, this is going to have redeployed here. It definitely should have done. And where's it gone? There it is. There it is, yes. So it's changed it there. You can see 80A, and in our audit logs in Seldon, we should see a further change. There it is. So it was literally created a minute ago at 6:20, and we can see the change again. It was an image change, which is very significant. We can see now that 7.6a has changed to 80a, and that is exactly the change that we wrote together here. That line can now be traced from my laptop all the way through our build stages, right out to the Seldon model, which sits behind our claims app. And so this was the 25th of Feb. And if we now have a look at, say, the 26th of Feb, there we go. So the model was performing very, very badly at this stage, but we retrained it, and the actual and the forecasted figures have now gone close together. We can see how the model is performing. We can see we gave it it's essentially a change point in the time series forecast. It's much more capable of tracking it. You can see it's sort of lost these blue bands around it are showing a level of uncertainty around the prediction. It's kind of struggling to figure out what's going on, but it's definitely realigned itself with the actual. And you can imagine, you know, our business application is now receiving better data. And obviously this is just essentially a silly little thing, but this obviously could be any business application. You know, an application like this could, in theory, go and make some automated changes to the level of capital that we hold against our business, or perhaps it would change a marketing budget and the amount of policies that we're happy to go and sell because the claims volumes are changing so much. I'm not saying that's what we would do, but in theory, you can see how an application sitting completely outside of Seldon can integrate with Seldon in a great way. And we didn't have to take this application to Seldon. So it's working very closely with Seldon. It's making a standard HTTPS request to Seldon, but we didn't have to. This is a completely standard web app. There's nothing kind of Seldon special. No sort of special Seldon config had to go into the business application. So you don't end up with that kind of spaghetti of dependencies. This could be any application, and it just sends a request off to Seldon and says, can I have some data, please? And that's what I wanted to show. So I'm going to pass you back to Jordan.
Thank you very much, Alex, for that amazing demo. It was really good. Great. 2 seconds, I'll get my screen back up. I would like to say thank you very much, Alex, and a special thanks to Tom Farrand for coming along as a guest speaker to the event. It was you didn't have to do that, and it's much appreciated. So thank you very much for that. And with that, I will get through these slides to thank you for coming. And does anyone have any questions about anything? If you don't have any questions now, I'll stick around for a few moments.
Somebody's put their hand up, Jordan. Can you see?
Yeah, I put my hand up. Hi. So I'm just trying to work out the kind of use case for this of kind of using a more integrated data system like Databricks, for example. If you go to Azure, you'll have everything there. It's got all your compute power there. Is the use case for using this mostly around the flexibility that you have enabled to use a lot of different technologies together, or could you just briefly explain those kind of benefits? That's okay.
Yeah, for sure. And for me, Alex can talk after this, but for me, yeah, flexibility is a big thing. And I feel like with Seldon, it's quite quick to implement too into production. So we can get stuff into, from experimental phase to production phase, and, the products in the market as quickly as possible with a variety and without any constraints.
Yeah, so I mean, thanks for that question. I have to say, I mean, you mentioned Databricks. So before I joined Covéa, which was less than a year ago, I was a massive user of Databricks. I was using it every single day. So I guess that gives me an interesting view of Seldon and Databricks. And I would say that Seldon is, like what you're saying, it's a hell of a lot broader and more flexible. I was showing there in my Seldon app that I could pretty much write anything I wanted, and and I was showing, say, the web app could be any app and sending an HTTPS request. Databricks is a lot more niche in what it's doing. It's essentially provisioning hardware for Spark jobs. You can use it for other workloads, but it starts becoming a bit cost ineffective. In my experience, if you're not using it for its niche use, whereas this is kind of your widely used Kubernetes and whatever it is that you want to run on there, you've got really fine-grained ability to change exactly what you're deploying to it. And from a platform perspective, Databricks is a lot more sort of wrapped up in terms of the platform, whereas this, as I was saying, it's Kubernetes. It's got all those different kind of open source components that Tom Farrand was talking about, and I would like fairly confidently say that that's going to work out to be more cost effective for businesses like, say, Covéa, where there's going to be different sorts of workloads being handled.
Thank you.
I've just noticed there's a question in the chat from Tom Clay, so I'll pose this to Alex and Jordan. How does Seldon/Kubeflow allow you to implement the latest ML research into your models?
Oh, I was on mute. I would say, how does it allow you to implement it? So I would say it allows us to implement it at any type. So the flexibility is there, as Alex just mentioned. There's no constraints in, for example, which model we use, which algorithm we use. So there's a lot of stuff there we can make use of. As for the Kubeflow, there's a lot of aspects within Kubeflow that allows us to do experimentation with whatever algorithm we need. So pass it on to Alex with his thoughts. He has a more in-depth answer probably.
Yeah, so I mean, I guess the demo that I just did probably illustrates that. That was using the profit package that Facebook open sourced. I sort of doubt that existed when Seldon was first created. It's no one at Seldon would have needed to have a conversation about how are we going to let our users use profit, and no one had to make a request of Seldon, oh, we want to be able to use this new package. Do we have to pay you some extra money to do that? Because the platform is flexible. It's also flexible in terms of languages. So everything here was written in Python, but just a couple of weeks ago, I deployed something that was written in R, and it was very, very similar, which is really nice. Actually, something that we haven't spoken about was how similar the working pattern, how it feels to deploy something is, whether you're writing it in R or Python, which again is really handy for a business like Covéa, where we don't want to say, oh, we're Python or we're R, because we want to be able to use the two just interchangeably, and just as professionally as we would use one, we want to be able to use the other.
Thanks for that, Alex. There's another question there. Sam, so you mentioned that 90% of the models created. That was a quote from a report I seen online. Now, since working with Seldon, yeah, a lot of them have made it to, yeah, all of them can make it to production. It just so it's made it 100 times more efficient to get these products to ship to the market. So. And the market being Seldon, so that we can get them to our users. So yeah, a lot of them, it's much easier to. There's basically no constraints on getting models to production now, so it's a lot better. And the fact that we don't have to use that, we're less reliant on DevOps through the the pipelines and things like that. It's a lot better.
So is that all? Does that look like all the questions then? I think so. Yep. Well, thanks, guys. I'm Becky. I'm the technology recruiter. I'm going to hang around for a few minutes if anyone has any questions about Covéa in general. And thank you, everybody, for coming.